Okay, first problem I want you guys to look at log base 7 of 2x equals log base, actually let's make this 2x plus 1 log base 7 of 5x. Okay, I want you guys to solve that problem right there. Just a reminder, you're trying to cancel out the logs and then you guys solve the equation that's left. Okay, so now, if you guys remember, if I have a log on both sides, all I gotta do is cancel out the log. Remember, it has to be one log though, right? So one log on both sides, and the bases are the same. Now I just take the a values, set them equal to each other, and now I gotta just solve that equation. So I want you guys to figure out the answer. Solve that equation right there, okay? Work out the steps. Okay, second one. Okay, let's do log base 5 of 3x. Now plus log base 5 of 2x, just 2, not 2x, is equal to log base 5 of 18. Okay, only difference on this one now is that if you notice over here I had one log on the left side of the equal sign. On the other side of the equal sign I just had one log. But here I've got two logs on the left side of the equal sign and one on the right. So before I just cancel them out, I've got to combine these two together. So you got to combine those two. Okay, so in order to combine those, if I'm adding the two together, I'm going to multiply the a value. So 3x times 2, 6x. And now it's just like the last problem. I got two logs on both sides, cancel out the logs, and then solve for x. Okay, you guys find x, all right? Okay, so the next one. Let's do one very similar to that. Okay, so let's do number 3, log base 6. Actually, switch the marker. Of 3x plus 2. Actually, let's do, over here, let's just do 3. Okay. Log base 6 of 3 plus log base 6 of x plus 1 equals log base 6 of, I don't know, 7. Alright? Alright, so remember now you're going to have to combine those two. The only difference between this one and that one is that the second log, the a value has 2 terms instead of just 1. So now when you multiply these two together, distribute the 3 to the x and 1. That, when you combine the log, cancel them out, and then write in your answer. Okay? Or answer on the end puzzle will ask you which one is correct. Okay? Let's cruise on over here. Okay, a couple more here. Okay, now, what I'm going to have, number 3, we're going to have log base 4, and again, the base part, I just keep changing up. That part isn't what really matters. What is important about that is that they're all the same. You can't combine them unless they have the same base. Okay? So now, x, log base 4 of x, plus log base 4 of 2x is equal to log base 4 of 25. Sorry, not 25, let's go 50. Log base 4 of 50. Alright? So now, combine those two, right? And this is just an example for you guys to look at. So actually, we'll just call this an example. Multiply those together. 2x squared. Because remember, x times x, that's x squared. Now, I've got I've got one log on each side, one log. Cancel them out. Alright, but now I've got x squared, that's different. The other ones were just x, right? But now I've got this x squared. So first let's get the x by itself, 5 by 2. x equals 25, and some of you guys might say what to do now. It's x squared, I got to square root both sides. Now, square root of 25 is 5. However, remember there's always two solutions when you square root, so it's plus and minus 5. Okay? So I'm going to have you guys do one just like that. Okay, so your guys' problem is going to be log base 5 of x plus log base 5 of 3x equals log base 5 of 48. Okay? You guys follow the same steps.
Attention,
and you guys
ECU
solve that
students.
one.
Students without a class after lunchtime will take their lunch to go. Students who eat on campus must remain at least 6 feet away from others and put your mask back on as soon as possible. Be responsible, be respectful, and be brave.
Okay, now the next one, log base 7 of x plus log base 7 of x. We'll go, I don't know, minus 4, sure. All right, equals log base 7 of 12. All right, so I'm going to show you guys how to do this one. So this will be another example. And then I'll give you guys one to work on. So combine, right? So distribute the x. X times x, x squared. X times negative 4, remember multiply both terms, 4x, equals log base 7 of 12. Now I just have one log on each side. Cancel them. I get x squared minus 4, excuse me, minus 4x equals 12. Now the difference between this one and that last one is here all we had was x squared and a constant. Here I've got x squared, I've got x, and I've got a constant, meaning you have a, b, and c. Alright, so what I want to do here is instead of trying to square root, let's set it equal to 0. Take 12 away from both sides. I can't subtract that from that because they're all different terms, they're not like terms. So I get x squared minus 4x minus 12. So if you guys recognize this, I have 3 terms, so which means I got to do the diamond. Okay? So now, negative 12x, a times c, negative 12x squared, a times c, and then the b, negative 4x. Figure out what two values multiply to negative 12, add up to 6, add up to negative 4. Well, I think that'd be negative 6x and positive or plus 2x. Okay, so that works. Now, notice all I have is a 1 in front of the x squared, so I can go straight to writing the factors. So basically I'm using factoring to solve this. So I have x minus 6, and then x plus 2. And so now that means my solutions then are x equals 6 and x equals negative 2. Because remember, at this point, this is where we switch the sign, and it's the opposite. Okay, so that's how you guys solve those. And then I will give you guys problems like that to work on.
31.
This will be your last one. Again, this is in your homework packet, these types of problems. This is why I'm going over it with you guys. We'll do, I don't know, 8. Log base 8 there of x plus, again, we're all adding logs in all of these. Okay, so we're not subtracting, which I know would be divide, but I'm just focusing on this because this is what I saw in your guys' packet. Okay, so now x minus 5. I guess we could do plus 5, that's fine. And then equals log base 8 of 14. Alright, so go through the same steps. I want you guys to figure out the solutions. Again, this is going to end up being another quadratic, right? So you're going to have not just one answer, but 2 solutions, okay? So I realized as I was going through this in Zoom, I forgot to press the recording button. So I have all the notes here. I'm just going to kind of go through it with you guys. So what we did is initially we started by creating the unit circle. Okay, so this is from 9.5. And what we did is we started filling in all these missing values, and that's what part of your homework is. And when you guys watch the Ed Puzzle with Miss Menard, you'll see all that. Okay, so we know that we start here at 0. If I go up to this point, it's 30 degrees. The point in the middle between, in the middle of these two, it's 45. This is 60 degrees, because if you think about it, from here to here is 30, and that's like the same distance from there to there. Another 30 degrees is 90. All right, so now that's just the degrees, and you would fill in the rest all the way around. Now we did radians next, because remember radians is the same as it's the same as degrees, just another way to measure. If I go halfway across to 180, that's the same as pi, right? So if this is pi, that means that halfway between is half pi, or pi over 2. And then if I'm looking at between the beginning and half pi, well, the middle of half pi, or half of half pi, is 1/4 pi, or pi over 4. Okay, now for pi over 6 and pi over 3. So to get those values, the way we looked at it was, well, okay, from all the way here to here is pi, right? Now 30 degrees, I count, how many times do I have to count 30 degrees to get to pi? 1, 2, 3, 4, 5, 6. So I have to add 30 degrees 6 times. Okay, in other words, I'm breaking pi into 6 parts, hence that's why it's pi over 6. All right, then here, if you think about it, this is just another 6th, which is 2/6, which is equal to pi over 3. All right, so that's how we figured out those radians. The next thing we did was we looked at, okay, the point of the unit circle, or one of the big pieces of using it, is figuring out these values right here. And the way where those come from is, if I look at this point right here at 30, from 30 to the middle of it, middle of the unit circle, this distance right here is 1. And that's why the unit circle is called the unit circle, because the radius itself is 1 unit. Okay, so basically every length here, all these lines that you see here on the inside, they're all 1 unit long. Okay, so if I was to create a triangle from here and bring a side straight down to the x-axis, because if you think about it, guys, this is the y-axis, right? The line straight down the middle, and the one straight across is the x-axis. If I bring this line straight down, well, that creates a triangle, right? And so we rewrote that triangle right here. If you notice, that angle right there is 30 degrees. And I said that this is, the radius is 1, right? Well, the radius happens to be the same thing as the hypotenuse in this triangle. So the hypotenuse is equal to 1. And this is 30. And if you guys remember from last week, well, if this is 30 and this is 90, that means this is 60. This is a 30, 60, 90 triangle. All right, and so we use that ratio to figure out these other two sides. Because we know that the 90 degree, or the side opposite 90 and the side opposite 30, they have a 1:2 ratio, meaning that the side opposite 90 is twice as big as the one at 30, or across from 30. So if we said, okay, well, if that's 1, that means that this is twice the size as this side, so that means it's 1/2. All right, and then we talked about, if you use the steps and finding the missing side of x and setting up your proportion and cross multiplying, you would figure out that this side is equal to square root of 3 over 2. All right, so what that means for this is, if you think about it, on the triangle on this unit circle, at this point, that's a coordinate, right? It has an x and a y value. Well, if I think about the distance going up from the x-axis to this point, that's the y. And the distance going from this point out to where this triangle meets the x-axis, that's the x value. Basically the x and the y here. All right, so that means, and we just found that over here in this triangle. So this is the y value, which I plugged in right there, 1/2. And then this side is the x value, which I plugged in the right, square root of 3 over 2. Now, if I go up to 60, this is the exact same triangle, except now that short side is the x, and the longer side is now the y. So in other words, that's why these two flipped. And this became 1/2, and this one became square root of 3 over 2. Now the last one, the one at 45, we didn't really show the triangle, but we made the point of that this creates a 45, 45, 90 triangle. And if you use the same idea that this side is 1, and then use the 45, 45, 90 ratio, you'll find that those sides are square root of 2 over 2. And remember, if you remember a 45, 45, 90 triangle, the x and the y side, or the two legs, are equal, and that's why these two numbers are the same. Okay? So then in the beginning, the last 2 points here, at 1 and 0, this is 1 and 0, because if you think about it, if the length of this is 1, well then x is 1, and it doesn't go up or down, so that y is 0. And then it kind of flip-flops over here where it crosses at the y-axis, or at 90, it's 0, 1. Hence, that's why down here, if you think about it, this would be 0, negative 1. Over here would be negative 1 and 0. Okay? So we're going to use that. So you'll fill in the rest. Use your notes that you got from the puzzle. Or if you understand how this works, you could just fill it in just by the idea of looking at, okay, well, I've got to add 30 degrees here. The middle of that's every 45 degrees, and so on. Okay? So now what you're going to do is down here, it says use the unit circle to find the exact value of each trigonometric function. Okay? So basically, you're going to look for the cosine of these different values, or sine. All right, so in order to understand that, let's go back to the triangle again, right? Now, if I think about sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse, right? Now, let's think about that. The hypotenuse in all these triangles, remember, is 1, right? So if I was to just change this, and let's just say the sine now is the opposite over 1. Well, if it's over 1, well then it's just the opposite. So all I have to do is find the opposite side, and that gives me the sine. And for the cosine, it's adjacent over 1, so it's just the adjacent side. Now let's go back up here and see how that relates to the unit circle. All right, well, the opposite side from the angle is the y value, which means that the sine is equal to the y value. The adjacent side is the x value. So when you are looking for these values, that's why I wrote this here, if it asks you for the cosine of that value, of that degree or angle, then all you need to look for is the x value at that point. Same thing for if it asks for the sine, you just look at the y value. So let me show you how that works. So if I asked you for, let's say, the cosine of 30 degrees, you basically just go to 30 degrees on your unit circle and look for the x value. The x value is square root of 3 over 2. If I ask you for the sine of 30 degrees, you just go right to 30 degrees and take the y value. So it equals 1/2. What if I said, what's the cosine of pi over 6? Well, that's the same type of question, and just giving you it in a different, the angle in a different type of measure, right? Well, pi over 6 is 30 degrees. So literally, it's the same answer. And sine of pi over 6 would be the same as sine of 30. Okay? Well, what if, kind of like on this one down here, and so just to reiterate with these ones, 210 and 315, you'll have to find those around the unit circle by having completed. But what if it's negative? Then what do? Well, what you could do is convert that. And you can notice here, I added 2 pi, because if you guys remember from the previous lesson, in order to change this to a positive angle, or in radians, I add 2 pi. If it's in a negative in degrees, then I add 360. So that's the difference between these two. Now, I highlighted these two because in the homework and the post, I told you guys you don't need to do these two. I went over them in class just to kind of show you guys how they work. All right, so for tangent, well, tangent is opposite over adjacent, right? Well, we just said that opposite is equal to y and adjacent is equal to x. So tangent is the same as doing sine divided by cosine or y divided by x. And so that's how you find it on the unit circle itself. So we said, okay, well, if I'm, first of all, we changed this negative 60 into 300 by adding 360, right? Okay, then I had to say, okay, well, what are the values at 300? So I took out my completed unit circle here. Take out some of my older notes here. I went to 300 degrees, and I said, okay, well, here's the x value is 1/2. Here's the y value at negative, which is negative square root of 3 over 2. Notice how those values keep on repeating themselves all the way around the circle, right? Because everything's going by 30s. All right, so then I said, okay, tangent is y divided by x. So we did the y at that point, which is negative square root of 3 over 2, divided by the x value, which is 1/2. Now, if you guys remember how to divide fractions, remember you have to flip the second one or take the reciprocal, which is why it's now 2 over 1. And you have to change the sign to multiplication. Now, if you notice here, I crossed out the 2's because if I have a 2 in the numerator and a 2 in the denominator, and remember when you multiply fractions, you multiply across, by the way. If I have one up top, one down, they cancel out. And then all I have is a 1 in the denominator, so really all I'm left with is the negative square root of 3, and that's where this came from. And then tangent of 4 pi, well, think about it. 2 pi is one full turn, right? So that'd be at this point. 4 pi is just another turn. So right back to the beginning. And remember, it's y over x, and the y is 0, and the x is 1. So here, it'd be 0 over 1, which equals 0. So next page. All right, so the next page, what we talked about is, okay, it says use the reference angle to find the exact value for sine, cosine, and tangent of each of these angles. Now, what I said is, like, don't worry about where it says reference. Just use the angle itself and your unit circle, okay? So you're going to find sine, cosine, and tangent for each of these. What we did is I kind of helped you guys out by finding the tangent, because that's usually the little bit harder one, okay? You guys can just go to the unit circle and find sine and cosine like I showed you in the last problems. Now remember that tangent is y divided by x, and at the angle of 150, y is 1/2, x is negative rad 3 over 2. Hence why I set it up, the y divided by the x, 1/2 divided by this. Same thing, I got to flip the second fraction, reciprocal, cancel out any numbers that are like each other, that are on the top and the bottom. And then I end up with just negative 1 over rad 3. And the reason it's negative is because this value was negative, okay? Now, if you remember, I can't have a square root on the bottom, so I have to rationalize and multiply square root of 3 on the top and the bottom to cancel out that square root. Okay, so that square root of 3 times square root of 3 becomes 3, and then negative 1 times square root of 3 is just negative square root of 3. So that's where this value came from. And then you guys will do the same thing for these ones. Again, this was a negative one, so you can change it to a positive coterminal angle by adding 360 and then doing the same thing. This one, again, same thing, just look on your unit circle wherever 11 pi over 6 is. Now these ones down here describe which special right triangles are helpful to find the coordinates on the unit circle. Well, draw the triangle in the correct orientation on the given of the given angles and show the sides of the triangle with a radius hypotenuse of 1. So basically it's saying draw a triangle with these angles. So basically what I just showed you guys here, how I drew this triangle, you're going to do the same thing. Okay, so if you notice, I drew an x and a y axis, and I kind of like put a dot, kind of approximately where that angle is. 135 is about in the middle here in the quadrant 2. 150 is a little lower in the same quadrant. And then over here, 210 is right below 180, right? So now you guys are going to create a triangle. And what you're going to do is label your triangle like this. Okay, label the degrees in the inside of your triangle. Label the hypotenuse 1, because they're always 1. And then label the other sides what the x and the y values are. Okay, and you'll have to find those x and y values by just going to your unit circle. Okay, so if I'm looking at 135, I go to the 135, which would be here, and then I label the x. side, which is, remember, is the side on the bottom, the adjacent side, which would be, the one that runs along the x-axis, so this side right here, okay, potentially, here I'll kind of just form this triangle so you guys get the idea what I'm talking about. There's the triangle, right? And there's the angle. So here, this bottom side is your x, the opposite side here is your y, and then that's your hypotenuse, so label those, and that's what you're going to do for the rest of those. This one, all this one is talking about is saying, okay, if you're, when you are calculating with degrees, make sure you are in degree mode. And if you're calculating with radians, make sure you're in radian mode. So it says calculate sine of 60 degrees. And you need to be in degree mode when you type in degrees. But if you type in radians, let's say with Desmos, you need to make sure you're in radian mode. So, for instance, if I go over here to Desmos, and I type in sine of, now let's actually look at your unit circle real quick. The sine of, let's say, pi over 2 is the y value, right? So it should be 1. All right, so let's see what happens when I try to type pi over 2 here. Sine of pi over 2. Notice how it says 0.2. That's wrong. And the reason is because I typed radians here, but I'm in degree mode. So if I switch that, notice, boom, it goes to 1. Now, the same point right there is 90 degrees. So let's see what happens if I try to type 90 degrees here. Notice how it doesn't say 1, right? But as soon as I switch back to degree mode, now it's correct. So whatever you type into the function, sine, cosine, or tangent, you need to make sure it matches, the mode matches what you typed in. Okay, and then all you're doing here on that problem is answering these questions. Okay, if I type in sine of 60, sorry, and in degree mode, and then I type in sine of pi over 3 in radian mode, did you get the same answer? And explain why your answers are the same or different. What is sine of pi over 4? Okay, so find the sine of pi over 4. Make sure you're in the right mode. Which angles measured in degrees would have the same sine as pi over 4? So now go back to your unit circle. Once you find that value, go back to your unit circle now, and then figure out which angles measured in degrees would have the same sine value as, remember the sine value is the y, so go back to your unit circle and look at the y's. Which ones would have the same sine value or same y as pi over 4? Okay, so you know where pi over 4 is. Look at your circle and figure out, okay, where else? What other degrees, what other angles on this circle have y for that same y value, okay? All right, so then this last one, sketch a unit circle with an angle that measures 6 radians. Remember, if you guys remember, a radian is the distance from here, from the middle to the side of the circle, basically the distance of the radius. So you're going to kind of like sketch it. So if let's say, and you're making a circle, right? So you make that circle. Actually, let me do this on the whiteboard. Kind of started here. Okay, so I know that the radius of the unit circle is 1, right? So from here to here, that distance, I'm kind of try to sketch it. So I'm going to guess that the radian is about that long, or the radius is about that long if I do it kind of like as a curve. And then let me do it one more time. Okay, maybe about that long. Maybe about that long. And then kind of just sketch that out and see how many times it takes you to get all the way back to the beginning. Okay? Remember, you're doing 6 radians. And it asks you now, approximately how many degrees is 6 radians? About, as you sketch this around, about how many degrees is that? Using only your diagram, estimate the sine of 6 radians. So at that point, when you get to the end, what do you think the y value is? Okay, about what is it? Okay, just estimate. All right, then this one, these ones are all special right triangles. So this is the 30, 60, 90, set your ratio up. This is a 45, 45, 90, set your ratio up. That's 1, 1 rad 2. This one is 1 square root of 2 and 2. Go back and look at the lessons from last week for special right triangles if you guys want to see how to do those. Okay, that's it.